So in this video, we're going to talk about an introduction to sequences. This is really for like more of a calculus class. And so first I just want to define what is a sequence. So a sequence is an ordered list of numbers. And so these are two sequences. So I could just have 2, 4, 6, 8, 10, where the sequence ends at 10. But I could also have something like 3, 6, 9, 12, 15, and I've got this ... to show that it continues on. So typically this ordered list of numbers also has a pattern to it. So this is obviously going to be all even numbers. These are multiples of 3. So a sequence can really be defined however you want. These are just two examples. And sequences are usually represented with this a sub n notation. So this is a little n at the bottom of this. And so in a sub n is called the index, and so it indicates where a term falls in the sequence order. So just to go back to our 2, 4, 6, 8, 10 example, so if I wanted to use that index notation, so 2 would be my a sub 1, 4 would be my a sub 2, 6 would be my a sub 3, here's my a sub 4, a sub 5. So when you have a number here, that indicates what its place is in the sequence. So a sub 1 I know right away is the first term. A sub 5 I know right away that's the fifth term in the sequence. Now sequences can either have a finite length or they can be infinite in length. But when you are talking about calculus, typically we are talking about infinite sequences. So that's really what we're going to focus on. Okay. So a sequence is also usually paired with a formula. So I've got this a sub n, and so it really works like any other formula that you can think of. But then kind of buried in this is this idea that this is going to be a list. So if I had the sequence a sub n equals 2n plus 1, that list would come with brackets for the list, and then I would start plugging in values of 1. So when n equals 1, my sequence is 3. When n equals 2, this will equal 5, and then 7, 9, 11, so on and so forth. So a sequence usually is accompanied with this list with bracket notation. Okay, just to do one other one just for funsies. So let's say I have something like b sub n equals n plus 1 over n. So again, if I wanted to do that same sequence notation, first term would be 2 over 1, then 3 over 2, 4 over 3, so on and so forth. So you can really define a sequence however you want. So just to get used to this, why don't we just write the first 5 terms of the following sequences? So I have 2 sequences here. So just to give you a moment to kind of breathe and think about all of this, what I would say is maybe pause for a second and think about what is a sub n equal to 1 over n? What are the first 5 terms of that? So go ahead and write those out and hit play when you're ready. So remember n factorial. So this is the idea that I multiply each term starting at n until I get to the end of this list. So if I start with a sub 1, so that's going to be 1 over 1 factorial, so that's just going to equal 1. For my a sub 2, that's going to be 1 over 2 factorials, so it'll be 1 over 1 times 2, so that's just 1 over 2. For a sub 3, that's 1 over 3 factorial, so that's going to be, typically we start with the highest number first. I don't know why I did that in the previous one. So this will be 1 over 6. A sub 4 is going to be 1 over 4 factorial. So alternatively, I can just think of taking 4 times the 6. So this will be 1 over 24. And then a sub 5, this will be 1 over 5 factorial, and that's going to be 1 over 120. So those would be my first 5 terms. Now, if I wanted to write that in a list notation, I could write this as 1, 1/2, 1/6, 1 over 24, 1 over 120. And then I would again put those ... just to indicate that the pattern continues. And you can kind of see from this now that some sequences are not as obvious as to what the formula might be. If I just gave you this list of sequences, it might not be clear what the formula for it is. So some of them can be pretty hard. So I've got another one here. So once again, I would just maybe pause here and hit play when you've written out the first 5 terms. Okay, so for my first one, so I'm going to have 2 plus negative 1 to the first. So that's really 2 plus negative 1, so that's going to equal 1. And then for my a sub 2, this will be 2 plus negative 1 squared. So that'll just be 2 plus 1, so that equals 3. So for this sequence, you can actually see that now that I'm getting to the third term, this just ends up repeating. So this sequence just bounces back and forth between 3 and 1. And that's totally fine. A sequence can bounce between just two numbers. It could be an ongoing list of numbers. Anything can happen with it. So it just depends on what the formula is. So another type of sequence that we're interested in is what's known as a recursive sequence. So with a recursive sequence, this is a sequence where the first terms or term are given in subsequent term, and then subsequent terms depend on the value of the previous terms. It's probably easiest just to show you an example of this. So this is a recursive sequence. So my formula, so you first look at the formula. A sub n is defined as n times a sub n minus 1. This is referring to the previous term in the sequence, all of that divided by n minus 1. So this sequence refers to a subsequent term. And so if you wanted to make the next term in this sequence, you have to know where this sequence is starting. So I have to be given a sub 1. So let's just write this out to a sub 5. So if I wanted to do my a sub 2, so first of all, what would that formula look like? This would be a times a sub 1 over 1, right? So this is always referring to the previous term. So if I'm on a sub 2, then I need to refer to a sub 1. And now we can pretty clearly see like why I needed to know what a sub 1 was. Otherwise, I couldn't have done anything with this. So then for my a sub 3, so I'll take 3 times a sub 2 over 2. And so that's going to be 3 times 4 over 2. So that'll just be 6. And then for my a sub 4, so that'll be 4 times a sub 3 over 3. And so that just equals 8. And then I'll cram in a sub 5 here. So that's going to be 5 times a sub 4 over 4. And so that will equal 10. Now, what's kind of interesting about this, actually, if you look at the sequence that we wrote out, my terms are 2, 4, 6, 8, and 10. So this ends up so far just being the even terms. So it just so happens that this particular recursive sequence worked out like that. Anything can happen with these recursive sequences, but this I just thought was kind of amusing that this gave us a really well-known sequence of terms, and yet you can also define it recursively. Okay, so that is just a quick intro to sequences and what they are. That's all I wanted to talk about in this video. In the next videos, we'll discuss a whole bunch of things about theory. So I'm going to leave it there. If you found this helpful, love it, of course, if you hit the like button or the subscribe button. And I will talk to you guys next time. Bye.